Now how is my voice, my dear friends? Is it okay now? How is my voice now? Is it okay? Dear friends, please let me know if it is okay or not. Voice is now better. Okay, fine, sir. Thank you. Thank you. Right. So the topics for today's class are the linked list, stacks and queues. Thank you, sir. Thank you. Thank you very, very much. Okay, sir. And this is the node structure of a singly linked list. Okay. We are having taking a simple node structure where you are having only a integer data and a link to the next field or next link. We call it as self-referential structures. Okay. Now, how you traverse a linked list, my dear friends? If it is a singly linked list, what is the time complexity for traversing a single linked list? Suppose you are having this particular singly linked list. We start with a pointer say P and which initially points to the start. Am I clear? That is what start is pointing to. P is also pointing to that. As long as this P is not null, you are going to continue like P is equal to P link. P is equal to P link. P is equal to P link, P is equal to P link and P reaches null, we stop it. So the time complexity for traverse in a singly linked list is theta n. The time taken for traversing a singly linked list is theta n, my dear friends. One more important thing which is called search in a linked list, singly linked list. What about search, my dear friends? If you want to search for 55, what you are going to do, my dear friends? You start with P is equal to start and you check the P data. Okay, as long as P data does not match with the required value, you are going to traverse like P is equal to P link, my dear friends. Of course, once P becomes null, you obviously automatically stop here. So what is the best case complexity for this? What is the best case and what is the worst case complexity? What is the best case and what is the worst case complexity, my dear friends? Yeah, obviously binary search is not suitable with linked list, my dear friends. So the best searching technique, okay, is linear search, right? So best case we can find the search element in the first node itself, that is the best case, and the worst case is very good Rishav Datta, very good Saubhagya, Sridevi very good, and Aryan Kaurav doing well. So it is theta n, my dear friends. It is theta n, my dear friends. Okay. See, yesterday we discussed about trees and the properties, my dear friends. Yesterday's class, those who missed can just go through that also, right? That would be very interesting. So it is like this: P we search, P data is equal to the search element or not. If not, P is equal to P link. Again, P is equal to P link. See, once you find the search element, you can come out of the loop, right? Now, please tell me, for inserting a node in a singly linked list, what is the time complexity? What is the time complexity for inserting a node in a singly linked list or insert at the beginning of the list? See, again, insertion in a linked list means, singly linked list means, you can either insert at the beginning of the list or you may insert at a particular position or after a particular node, or you may insert at the end. So worst case complexity, we always write it as insertion will be theta n complexity, we can write it. But insertion at the beginning, insert front. If you want to insert front, this can be done in theta 1 time, my dear friends. Because insert at the beginning or the front of the list, we just need to create a new node. Let us call it as some PTR. Then what you need to do, PTR link we need to update it to start. Then start need to be updated to this. So this is how, just modifying two link pointers, we can insert at the beginning of the list in a constant time. So at the beginning, if you are inserting, it will take theta 1 time, my dear friends. But if you are inserting somewhere at the middle, suppose you want to insert after this particular node, your pointer should go up to here. Am I clear? You should move a pointer up to here. Am I clear? Then what is this? This is the new node which you are creating. Am I clear? So this is the new node. Let us call it as new node n. What you need to do? The new link is equal to PTR link, then PTR link is equal to new. So here also we are modifying just 2 pointers, my dear friends. Here also we are modifying just 2 pointers to insert this new node. Correct or not? And this will take what is the complexity. For insertion here, what is the complexity? You don't know the position. It may be towards the end also. So you may need to traverse the entire linked list. So the time complexity for, see, only if you know this particular pointer, if this pointer is known, it can be done in theta 1 time. But no one told you that this pointer is with you or not. So you may need to traverse up to that. If you need to traverse, then it is theta n. If you are having PTR, if PTR is available, if PTR is given, then the complexity would be theta 1, my dear friends, if PTR is given. So always read the question carefully, whether PTR is given or not, they'll mention clearly. Based on that, you answer your question, my dear friends. Am I clear? Based on that, you answer your question. And what about inserting or inserting at the end? What about insertion at the end? Of course, you have to travel till the last node. This is a new node. Okay. Of course, the new node link should be made null, and you can make PTR link is equal to new node. So with this, what happens? You are going to insert a new node at the end. So in general, insert at the front will take theta 1 time. Insert middle in the sense not exactly middle, sir, somewhere, okay, at a position, maybe kind of position, or insert end. See, if nothing is mentioned, we have to take them as theta n time, my dear friends. If nothing is mentioned, we have to take the time complexity as theta n. Am I clear? If the pointer is given, that is mentioned, with that can you manipulate it or not? Check it. Then it would be theta 1 time, my dear friends, because just pointer manipulation can insert the new node in the linked list. Right? Now what about deletion, my dear friends? Suppose you want delete front. You want delete front, delete a position, or delete end, or last node, delete last node. Please let me know the time complexity for these three, my dear friends. Assuming only we are having pointer to the first node. What is the time complexity for deletion of a node from a single linked list? Assuming we are having only pointer to the first node. Very good. It will take theta 1 time. It's very simple. Directly you can change the pointer to the next node. Delete a position means, see, again you have to traverse till that particular position. Suppose a position pointer is given and you need to delete that particular node. Am I clear? In that particular case, what you can do is, you can just shift the pointer to that can be easily done, or you can traverse. Actually, if you want to delete a node, we need to have pointer to the previous node. If you want to delete this node, we should have pointer to this particular node, my dear friends. Then it would be easy for you to delete this node. Then it would be easy for you to delete that particular node. Yeah, Vengadeshan, position you can say, but generally position, in the worst case, what is the position, my dear friends? Worst case position is n, so generally we take it as theta n only. Generally we take it as theta n only. Am I clear? Please remember that. Yeah, please answer this question. Please answer this question. Option D. Very good. Rishabh says D. Prasenjit Biswas says N. Okay, D, very good. See, because number of comparisons needed to search a single linked list of length n. See, it is a linear search. Obviously, number of comparisons you are doing here is linear search only, because you are having, if nothing is mentioned, we assume that for a single linked list, the pointer to first node is only available. So accordingly, you answer. Am I clear? Suppose if they mention something about pointer to what node is available, accordingly you can change your answer, my dear friend, but by default we assume that we are having pointer to the first node. That is how we can access the entire linked list, my dear friends. So this is theta n. Next question. What is the worst case time complexity of inserting n elements into an empty linked list if the linked list needs to be maintained in sorted order? What is the worst case time complexity of inserting n elements into an empty linked list if the linked list needs to be maintained in sorted order? Theta n, you can do it. Rishodhatta says n log n, and Kaustubh Nageshwar says C. See, my dear friends, insertion in a sorted list. If you want to insert in this particular sorted list, first of all, the new number which you want to insert is say 20. New number you want to insert is 20. You have to reach this particular position, my dear friend. We should have pointer to the previous node. So we have to traverse till that particular position. So we have to reach the position. See, always here it is not like insertion front, insertion middle, insertion end, sir. It is always insert at a position only. Insertion in a sorted linked list means insertion in a position, and the worst case complexity for insertion at a position for a sorted in a linked list is theta n. Am I clear? So for inserting one, what will be the time complexity? I am telling you roughly, but now I'll give you the detailed proof for that, why it is theta n square. But generally for one it is theta n, means for n it is roughly theta n square, like that you can say. That is not exact correct answer, but I'll tell you how it happens. So you have to reach this particular position. This is the node you are having. This link is to be updated with PTR link, and PTR link need to be updated with this. Am I clear? Now out of this 1 and 2 operations, can you interchange the order in which these operations performed? Can you interchange this order in which these operations can be performed? That is, first I want to do second one. That is, can I do this first and can I do this second? Okay, you can't do this. So because in examination sometimes what happens, they'll give you which of the following is correct. In that they may give you the order of operations. Here the order of operations is also very important. Please note that. Now look here, sir. Suppose you are having empty sorted linked list. To insert the first node, how many elements you have to search? Nothing, because empty list na number of elements to be searched is 0. To insert this second element, because already one node is there, you have to search with that. That is, one search will happen. To insert this second element, you have to make 2 searches in the worst case. You have to make 2 searches in the worst case. To insert the fourth element, worst case, you have to make 3 searches. So continuing this way, to insert the nth element, we need to make n minus 1 searches, my dear friends, which is nothing but sum of first n minus 1 natural numbers, which is n minus 1 into n by 2, my dear friends. So this is theta n square, dropping the lower order terms and ignoring the coefficient of highest order term, you get order of growth notation. It's not n into n plus 1 by 2, n into n, okay. That constant variation does not matter. Some people says for inserting first element also they calculate that particular search, because first empty list na, first node is directly inserted, second node after search it is inserted, third node after search it is inserted. So in that case you get n into n minus 1 by 2, my difference. That is the difference. Is that clear? Because it is sum of first n minus 1 natural numbers is n minus 1 into n minus 1 plus 1, that is n divided by 2, my dear friends. So the answer for this is theta n square. If you want to insert into a sorted linked list n elements, the time complexity would be theta n square, my dear friends. Nice. So let us see the following code, my dear friends. I'll just move out of the frame so that you can read the question completely. Please read the question completely, my dear friends. The following C function takes singly linked list as input argument. It modified the list by moving last element to the front of the list and returns modified list. Some part of the code is left blank. You have to identify what is the correct option. The order also you have to find, sir. Okay, sometimes you know what to do it, but the order of operations is very important. So I'll just you understand, right? Let me give you simple example here. We are having this simple singly linked list, sir. Let me give you some 4 nodes in this, and we are having pointer to the first node. He is calling it as head now. Let us call it as head. It is a pointer to the first node. Okay, this is the linked list we are having. What is saying, sir? It modified the list by moving last element to the front of the list and returns the modified list. That is what you are doing. This last node is there, no? So this particular node is inserted. It is removed there and it is to be inserted at the front, and this head to be pointing to this. This is what we need to do, my dear friends. This is what we need to do. Am I clear? So let us do that properly. Let us give some numbers: 5, 15, 10, 8. So we are having pointer to the first node. Let us see how he is tracing this particular code. Now let us see how he is tracing this particular code. We are having 2 pointers P and Q. Am I clear? If head is null, yeah, head next is null, return head. That is, if you are having empty list, yeah, single node, the operation is obvious. There is nothing to do because you want to delete the last node and insert at the front of the list. When you are having empty list, nothing to do. If you are having single node, nothing to do. So that is what it is doing, sir. It is doing for empty list or single node, there is nothing to do. But otherwise what he is doing, he is making Q null and P is pointing to head. See, P is called, generally we call this P as current node and Q as previous node. So we always keep track of 2 nodes, one pointing to the previous node, one pointing to the current node. See, why 2 pointers, sir? Because this fellow will identify the last node and you need the pointer to the previous node because you want to cut this particular part. You want to cut this particular part, so you have to make that last link null. Otherwise, it will keep on moving like that. Okay. So Q is actually the previous pointer, P is pointer to the current node. Now what is doing, sir? As long as P next is not null, what you are doing? Q is moved to P, Q moved to the position of P and P moves to the next position. P next is not null, then what happened? Q moves to the position of P and P moves to the next node. P next is not null, Q moves to the position of P, that is Q points to P, that is P is pointing to some node now. Now Q points to the same node and P moves to the next node. Now see here, P next is null, P next is null. Now what is that you want to do, sir? This node has to be deleted and it has to be inserted at the front. See, if you want to do it, you already know that this is the last node. So this link can be made null. Then this P node, you need to take it and P next you need to make it equal to head. Then head need to be made equal to P, my dear friends. So here what is the order of operation? First you need to make Q next is equal to null. Q link he is calling na, Q link you have to make it equal to null. So this you have to make it a null. Then after that what happens? This P node you are having na. So P link, which is initially here, P link is null actually, that we need to make it equal to head, that should point to head, that is P. I remove P here and write it here, sir. P is here na, P link you need to make it equal to head, then you need to update head is equal to P, my dear friends. Update head is equal to P. So head should point to this. So with this what happens, the last node is cut from the singly linked list and it is inserted at the beginning of the list. So this is the order of operations. Now if you see the first one, he is making Q null. Option A is making Q null. That is wrong. If you make Q null, what happens? This linked list, whatever nonsense you are doing, this will become something like this. You are making it null, means this node is still available there only. So it is like, something like this may happen. And head is this, it may become a circular linked list, my dear friends, with this operation. So you have to be very careful with this operation, because here you are not making a circular linked list. So this operation is wrong. Next one, Q next is null, that is fine. Then head is equal to P. See, directly if you say head is equal to P, you lose the pointer for the first node. So this is wrong operation. This order is not correct. Next is head is equal to P. Again you lose the pointer to the first node. This is wrong. So the correct order is P next is head, P next is head, head is equal to P, and Q next is null. Okay, this Q next null, anytime you can make it, my dear friends. After that also you can make it null. So D is the correct option. So what is the correct option for this? Option D is the correct option. Hope you understand, sir. Is the idea clear? Okay. Q next null, you can make it at the beginning or at the end. Am I clear? That is the idea. Wonderful. This was last year GATE question, recently solved, but I thought reversing na, so it will again refresh your idea. So I just want to do it once again. Consider the problem of reversing a singly linked list. Which one of the following is true about the time complexity of algorithm that solve the above problem in order 1 space? Order 1 space. Reversing a singly linked list. See, for those having problem with the reversing singly linked list, this is a simple theta 1 time, my dear friends, simple problem only, but let me explain. See, we use 3 pointer to reverse the singly linked list, my dear friends. See, obviously one pointer is pointing to the previous node, one pointer to the current node, and one pointer point to the next node. So we have these 3 pointers: previous, current, and next. That names also generally we give beautifully so that we can easily remember this logic. So initially this previous fellow is made null. Here when I kept it means it is null. Initially it is null, my dear friends. Initially it is null. This is null. Now what I make? P points to start. P points to start. Now we continue as long as this P is not null, we continue this process, my dear friends. As long as P is not null, we continue this process. We create a node, we create a pointer next which point to P next. Next is equal to P next. Now because you got the address of the next node, you can remove this link and this can be pointing to previous. Now previous move to position of P. Now what you need to do? You have to move P to the P next. Now if P is not null, this process need to be repeated, my dear friends. So the process is very simple, sir. If you want to do reverse, okay, starting with the start node, first thing we have to do is we have to make P is equal to start and Q is equal to null, or P means we are using that P and next na. Previous you are calling na. So previous you can create it which is null initially. P is pointing to start. As long as, I'll write it in the next line, sir, because it's a continuous code. Here I am writing next part. As long as P is not null, you continue this process. As long as this P is not null, you continue this process. Next is equal to P next or P link. And P link is equal to previous P link is pointing to previous. Previous now meets P, the current pointer, and now P moves to P link. Yeah, so P is equal to next also you can say. Now this while loop is repeated, my dear friend. This while loop is, it is a pseudo code, not an exact code, sir. Pseudo code. It repeats. Now again what happens? First thing we are going to do is, next will move to the next node, P link. P link is made to the previous, and previous moves to P, my dear friends, and P moves to P link. Again the story continues. Next is P link. Next is P link. P link is previous. Previous moves to the P, and P moves to next. Again it is not empty. Continue the process. Next is P link. P link is equal to previous. Previous moves to P, and P moves to P link. Now P is null. The story is completed. Once you come out of this, what you need to do is, you have to make start is equal to previous, because this is the new start point. So you have to make start is equal to previous. So start node will be this, my friends. Start node will be this. So with this what happens? You are going to get the reverse of the given singly linked list, my dear friends. So this can be done in theta n time. So the complexity is theta n time. The best algorithm for problem takes theta n times in the worst case. Hope you understand. Wonderful. Next question. In a circular singly linked list organization, insertion of a record involves modification of how many pointers? Circularly singly linked list organization, insertion of a record involves modification of how many pointers? Actually, in a singly linked list, insertion at the front, we require the new node to be created. New node link need to be updated to the start node or head node, and head to be pointing to the new node. 2 pointers you have to manipulate. Suppose you are inserting at somewhere at the in the middle. Okay, let me just show you this. This is a circular linked list, my dear friends. We are having this particular organization. Suppose you want to insert at a particular point, my dear friends. In a circular singly linked list organization, insertion of a record involves modification. Modification of how many pointers? Okay. See, suppose you want to insert at the beginning. Suppose you are having this particular pointer. What you need to do, sir? This is a new pointer. What you need to do? PTR link is equal to P link, and P link is equal to PTR. Will make it insertion at the beginning. So how many links you modified? 2 links you modified. Suppose you want to insert here. You should have a pointer to this, and this pointer is P. So P link is equal to PTR link, and PTR link is equal to P. How many links you are modifying? 2 links you are modifying. Even if you are inserting at the end also. See, anywhere if you want to insert, the new node link has to be P link, and P link must be equal to new node link. So 2 modification of the pointers are needed for this, my dear friends. Just 2 pointer modifications for insertion. It's a very common question, my dear friends. Whereas in a singly linked list, insertion at the end, we just need 1 pointer, because last node need not be connected to anything. So in that particular case, just last node link, if it is a singly linked list. Insertion at the end, just 1 pointer manipulation we can do it, my dear friends. 1 pointer manipulation you can do it. But if it is a circular linked list, for every insertion, 2 pointer manipulations need to be done. See, that's what, if you keep the pointer to the last node, if you keep the pointer to the last node, what happens then? If you keep the pointer to see, the idea is, if you have, we need to assume that you are having appropriate pointer to that particular node. Suppose if you want to insert at the center, my dear friends, then you have to move a pointer till that point. then how many pointer manipulations happen? In that case, if you see, you have to say multiple pointers then. In that particular case, if you see, if you want to insert at a particular position, you have to move this pointer to that till that particular point. Na? So here we assume that we are having an appropriate pointer to the previous node and this node. Then to insert, how many pointer manipulations need to be done? Actually, it need to be elaborately given, my dear friends, because old gate questions, they assume certain common assumptions, they ask that question. Hope you understand, Saubhagya. Is the idea clear? If your argument to be valid, then insertion at any point also we need to make multiple pointer manipulations. Is that clear, Mr. Saubhagya? Did I made my point clear, Babu? Clear or not? Suppose we are using singly linked circular list without a head pointer, and are using the convention that the list pointer L points to the last node in the list. That is, we are having a singly circular linked list. Okay. Actually, they mentioned that at least 5 nodes are there. Whatever. So we are having the pointer to the last node. This is the organization we are having. Assuming that list L has at least 5 elements, yeah, what would be the effect of L next is equal to L next next? Please answer the question. Yeah. Which operations are? That's it. Assuming that this is the operation we are doing, only single operation. It would delete first element. Yeah, very good, very good. So simple story, my dear friends. We are having at least 5, let us take 5 elements only. We are having this fellow. What is that you are doing? L next, that is this pointer is pointing to L next next. That is, this is pointing to this fellow directly. Means obviously this fellow is gone. That is, the first node in the list is vanished. First node in the list being removed, sir. It would delete the first node in the list being represented. Very good. Now let us move on to the problems on stacks. These are very, very interesting. Problems on stacks are very, very interesting. Using a stack, determine the number of different permutations of the ordered list of integers 1, 2. That is, if I am having numbers 1, 2, using stack, what permutations I can get it? What permutations I can get using stack? See, first we will see for numbers, 2 numbers, 3 numbers cases. If you understand that properly, many problems can be solved just like that. Am I clear? Instead of using proper stack only, we can answer the questions very quickly, my dear friends. Let us see this now carefully. Very good. So if you are having just numbers 1, 2, if I am having the stack, I can push 1, pop 1, push 2, pop 2. Yeah, using the stack 1, 2, I can push 1, I can push 2, then pop 2, pop 1. So these are the permutations, stack permutations. These are called stack permutations. Actually both permutations are possible. Both permutations are possible. Very good, very good. With 1, 2, 3. See Deepak Gupta, I know that, but I am interested in one more very interesting point, that if you understand, sometimes problems can be solved very quickly without doing this entire nonsense. So I am interested in that. No, no sir. For BCA people, eligibility is not there for GATE. We need to have MSc or MCA, okay, equivalent examination. 1, 2, 3. See here, total 6 permutations will be possible. Total 6 permutations will be possible. That is, you can push 1, pop 1, push 2, pop 2, push 3, pop 3. This 1, 2, 3 is possible. Okay. First let me show you what are the permutation, normal permutations. 6 permutations are there, no? 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 1, 3, 1. Now this is possible. Wonderful. Now let me remove this. Let us try 1, 3, 2. Can I get 1, 3, 2? So for if I want to get 1, 3, 2 means push 1, pop 1, push 2, push 3, pop 3, pop 2. So this is also possible. Next one, if you see 2, 1, 3, can I get 2, 1, 3? Let us see 2, 1, 3, we can get it or not. 2, 1, 3, you can get it or not, let us see. 2, if you want to get first 2 means till you get 2, you have to push everything inside the stack. So 2 can be popped out. I know your answers, wait sir, give me some time. 2 is popped, am I clear? Then what happens, you want 1, 1 is popped, then 3 pushed and popped. So 2, 1, 3 is possible. Very good. Next is 2, 3, 1. 2, till 2 you have to push everything inside. Till 2 you have to push everything inside. Then 2 you pop it. Then you want 3 means push 3 and pop 3. Then you pop 1. So 2, 3, 1 is also possible. What about this 3, 2, 1? What about this 3, 2, 1? Push 1, push 2, push 3, pop 3, pop 2, pop 1. You can get it. And what about this particular permutation? What about this particular permutation? 3, 1, 2. 3, 1, 2 is not possible. 3, 1, 2 is not possible. Okay. Now look here sir, I am having 4 numbers. I am having 4 numbers. Please tell me, is this permutation possible or not without using stack? Without using stack, you have to tell me, is this permutation possible or not? Can you tell me whether this permutation is possible or not? Don't have to use stack. You should not use stack. See my dear friends, this remember 3, 1, 2. Third one, first one, middle one. 3, 1, 2 permutation is never possible. Not only this, if you are having ABC, 3 sorted numbers if you are having, CAB is never possible my dear friends. So in your permutation, if you find this CAB pattern, it cannot be stack permutation. It cannot be stack permutation my dear friends. If you can able to identify this pattern, like you know CAB, then it is not stack permutation. So with this simple idea, that is, the given permutation should not contain any pattern of the form CAB. If it contains CAB pattern, then it is not stack permutation. Okay, please remember that. That is very important idea my dear friends. Remember this, then you can remember all that. And many people are answering very quickly. An item that reads as input can either be pushed to the stack and later popped, and printed directly. Out of all possible permutations, how many of them can be obtained using a stack if the input sequence is 1, 2, 3 and so on and in that order. So, number of such stack permutation is given by Catalan number. What is it called? CN, Catalan number. It is called Catalan number. Yesterday also we seen many Catalan numbers. Today also we are seeing Catalan numbers. Catalan number plays very important role. Catalan number plays very important role. So, number of possible permutations of the elements 1, 2, 3, 4, 5 using stack. How many possible permutations of the elements 1, 2, 3, 4, 5 using the stack are possible? Please answer this. So, you just need to find C5. C5 means 1 by 6, 10 C5. It is 42. Okay, good. Which of the following cannot be obtained in the output using a stack, assuming that the input sequence is 1, 2, 3, 4, 5. Without using stack, can you do this? Of course, using stack you can do it, sir, very simple problem only. But with observation we can solve this problem. With observation you can solve this problem quickly. Try to identify that CAB pattern anywhere or for any 3 elements which are correct order like ABC. If you can find CAB pattern for them, then it is not a stack permutation. It is not a stack permutation. Option A. Is it by observation या complete procedure? Is it by observation या complete procedure? There can be MSQs also, Babu. See, generally in any interviews, first thing is, after generally asking your regular details, they'll ask you this particular question, your areas of expertise or interest. So, based on that, they'll take you to the next level. Am I clear? So, the shortlisting is wonderful thing, my dear friends. Congratulations for that. See, whatever areas you are comfortable, try to, okay, obviously any interviewer generally focus on the areas you are interested in. Then they'll take you to the next level depending on your interaction. That is how the interview processes will happen. Am I clear? They'll not come up with some question paper and ask you questions like this. It won't happen like this. Okay. So, it may vary from person to person, my dear friend. Based on your choice of interest, you can just review all the basic formulae, basic ideas, my dear friends. Common sense is the key for the interviews, what I suggest. Because you prepared, you already cleared the examination, maybe because of something. Obviously, they know you know certain results, certain ideas. Okay. So, they just see your, basic knowledge. Okay, open mindedness, they'll check it. So, you can prepare for some strong subjects, you can suggest them, they'll ask you questions from that, right? That is the idea. See, here you see 5, 1, 2. 5, 1, 2 is never possible. 5, 1, 2 is never possible. 5, 1, then 2 is never possible. So, with that you can easily say it is not possible. Okay, very good. Next one. Which of the following is not a valid stack permutation, my dear friends? Which of the following is not a valid stack permutation, my dear friends? See, if you can get observation, wonderful, sir. Otherwise, always you can try this. See, for those the observation method does not work, don't worry, sir. You can always solve this problem by detailed method like option A take. You want 4 first, na? Okay. A is the answer, not. See, 4 you can say. See, if you want 4 first means till 4 you have to push everything inside. Then 4 can be taken out. Then you want 3, 3 can be popped up. Then you want 5 means 5 you push and pop. Then you want 1 means how can you get 1 without taking out 2? This is not possible. Like that you can verify. Option B also. You want 2 with 1, 2, 3, 4 order. You want 2 first means till 2 you push everything, then you take it out 2 out. Then you want 4. So till 4 you push everything, then pop 4. Then you want 3, you can pop 3 from this. Then you want 1, you can pop 1. Then you want 5 means push 5 and pop 5, you can get it. That is not a big deal. Yeah, let me check, sir. Because some people may be interested in the full story. So observation may not be possible for everyone. So here you want 1 means push 1, pop 1. 3 till 3 you push everything, pop 3. Then 5 means till 5 you push everything, pop 5. Now everything is already pushed onto the stack. You can pop 4, you can pop 2, my dear friends. This is possible. Now what about D option? Same story. 2 you want means till 2 you push everything, pop 2. 4 you want, till 4 you push everything, pop 4. Then you want 3, it is available, pop it. Then you want 5, push it and pop it. Then 1, it is possible. All these are possible except A. I think in this you people are saying D is the correct answer, right? Why D, sir? Any observation? For D, any observation? For D, any observation? Very good, you people are rocked, wonderful. For D, see my dear friends, Prakash Babu, see generally marathon series or whatever series we conduct, okay, that is for review purpose. Am I clear? One thing is you need to understand all the results. PYQs will tell you the order in which you need to continue. Mathematics generally, I don't know which branch you belongs to, because for mathematics, computer science, we don't have 10 marks, maximum 4 to 5 marks you get it. For engineering mathematics, if you are seeing, for discrete mathematics, it may be around 10 marks. Again, it depends, my dear friends, okay, because in a single marathon session, what you prepared, all the questions may not be able to possible to cover in that. Am I clear? So you need to have your short notes. Am I clear? Then you prepare and you keep on doing this test series, and all these will help you in revising the concept and verifying whether your revision is proper or not. You are able to recollect things properly or not. Am I clear? See, you are asking like, shortcut. That kind of shortcuts are not possible. That will help you. This will help you to go to the next level. Okay, but only by this doing something is not advisable, my dear friends. You should have your short notes for your notes prepared for the entire year. Then this, whatever you are asking for, that will help you. But without revising anything, directly sitting in marathon series will not help you. Remember that. Please remember that. Yeah. So here 4 to 3 not possible. Very good. 4 to 3 not possible. Right? Which of the following permutation can be obtained in the input, in the output? Which of the following output can be obtained? See, actually the same problem cannot be, can be asked as can be, because MSQ 3 will be correct and 1 is wrong answer. Same question can be asked as MSQ. In that case, A, B, C will be correct answer. So you please be careful with this, my dear friends. You please be careful with this, my dear friends. The next one, which one is the correct answer? Which of the following permutation can be obtained in the output using a stack, assuming that input is a sequence of 1, 2, 3, 4, 5 in that order? I told you there can be multiple correct answers. Which of the following can be obtained? Only B can be obtained. Okay, only B. Very good. 3, 4, 5, 2, 1. Good. Only this fellow can be obtained. Super. Nice, you people are rocking. D also. Hoy. D also possible, huh? When there is a 312, how is it possible, sir? Pujara Babu. When there is a 312, how is it possible, first of all? You should not have 312 permutation in that, na? We should not have 312 permutation in that. Yes. It is not possible at all. Consider usual algorithm for determining whether a sequence of parentheses is balanced. What is the maximum number of parentheses that will appear on the stack at any one time when the algorithm analyzes this particular parenthesis? You have to answer this, my dear friends. Two, maximum two. So the algorithm is very simple. Whenever you see left parenthesis, you are going to push on to the stack. So the right parenthesis, when you get it, you are going to pop. Correct? So when you are having first left parenthesis, then you have left parenthesis, 2 you are having. So maximum, you keep track of the maximum. 1, 2 we are having maximum. Then right parenthesis means this is popped. Then this is popped. Then again left parenthesis, push it. Again left parenthesis, push it. Now you got 3 maximum. Then again you got right parenthesis, pop it. Right parenthesis, pop it. Again left parenthesis, push it. Again left parenthesis, push it. Then right parenthesis, pop, pop and pop. So maximum you can have 3 at any time, my dear friends. Maximum you can have 3 at any time, my dear friends. Yeah. See, by the time you reach the end of the list, but still some parentheses are inside the stack, means it is not a valid parenthesization, my dear friends. Like that also you can identify this procedure, right? This procedure can be used to verify whether it is a valid parenthesization or not. Very good. Assume that the operators plus, minus and into are left associative, that is left to right associative. This is power, which is right to left associative. The order of precedence of operators is power is highest, then multiplication, then plus, then minus. The postfix expression corresponding to the infix a plus b into c minus d power e power f is what? What is the postfix expression? See, my dear friends, here we are going to use the operator stack. So let me write this expression: a plus b into c minus d power e power f. See, if the new symbol which is coming, okay, so whenever a new symbol comes, you are going to push onto the stack, empty stack. Now the new symbol which is coming, the precedence of the symbol is less than or equal to stack top symbol. If it is smaller, what we need to do, sir? If it is smaller, what we need to do? The previous one need to be performed. So previous one we have to pop till you get the greater than one is available inside. That is, this stack symbol is greater than the stack top symbol, then you have to push it. If it is less than or equal to, what you need to do? You have to pop the symbols, then you have to push this inside. But for right to left associative, normally if precedence of symbol is less than stack top symbol, not less than or equal to. If it is less than, then you are going to do pop and append to the postfix string. Append to the postfix string, my dear friends. For right to left, this is what happens. For left to right, if it is precedence of symbol is less than or equal to stack top symbol, then you do it. So pop and append. So this variation you should remember, my dear friends. For right to left and left to right, that small variation you should remember. Rest of the story is same, my dear friends. So here what happens? We are having this particular stack, operator stack. A directly append to the postfix string, plus you push on to the stack. B you append to the postfix string. Now you got multiplication. Multiplication is having higher precedence, greater, then it has to be pushed on to the stack. Then you find C. Then you find minus. Minus fellow is having precedence less than into. So into is popped out, appended. Minus and plus are having equal precedence, then it is popped and appended to the postfix string. Then minus pushed onto the stack. Then comes D, append it. Then comes power. Power is having higher precedence than minus. So what happens? Power is included. Then E, appended. Then again power. See, it is equal to also you are going to push inside the stack. Equal to also you are going to push inside the stack because it is right to left associative. Then comes F. Now after F, all the symbols are completed. You pop and append to the postfix string, my dear friends. So ABC into plus DEF power minus. So that is option A. Straightforward question, my dear friends. You have to be careful only with the right to left associative fellows, my dear friends. Right to left associative, even equal to also you are going to push onto the stack. Even equal to also you are going to push onto the stack. That is a small variation. Sometimes in the examination, even that plus minus regular symbol also, they may change their order of precedence and they can ask you this type of questions. So be ready for that. Convert the following infix to postfix. Convert it to postfix, my dear friends. You need to write the expression. So here also we assume normal precedence of operators. First A is appended to the postfix string. You want, you can write it here also. A is appended to the postfix string, then star, then B is appended to the postfix string, plus is having less than or equal to precedence, then multiplication. So multiplication is popped out, then plus is pushed onto the stack. Then you get left parenthesis, push onto the stack. C, push onto the append to the postfix string. Then you get plus. When it is left parenthesis, you directly push onto the stack. Stack empty, yeah, left parenthesis, you push onto the stack. Then D, append to the postfix string. Then division. Division is having higher precedence than multiplication, push onto the stack. Then E. See, once you see the right parenthesis, till you get left parenthesis, you pop everything and append to the postfix string. So pop it, append to the postfix string, pop it, append to the postfix string, and right left parenthesis you pop it and throw it out. Now only plus is on the top of the stack, sir. Then we have minus. Minus and plus are having equal precedence, therefore plus is popped, then minus is pushed onto the stack, then F, finally minus. A, B star, C, D, E, division plus F. Very good, sir. Okay. So you can practice this postfix expressions, my dear friends. They are good for health. Actually, you can do this postfix expression without doing the stack and all, sir. We can directly, if you know the regular precedence of operators, you can construct the tree and you can write down post order. Okay. You can do this way also, like final, you all know the order of precedence. Accordingly you can create the tree, and from that also you can construct this fellow. Okay, because this is having first preference, then this is one, next we do, and finally is minus. Minus, you can construct this tree. Then for this particular fellow where plus is there, then this star A, B, then this parenthesized expression where you have plus and division. So division is having higher precedence, so then it is plus C, D, and then plus C. So you can convert into what you call this binary tree, expression tree we call it as expression tree. Then you can give the postfix expression for this. So you can draw this expression tree, and then you can do the post order traversal. The post order traversal give you the post order. What is this language I am using? Post order traversal can give you the answer for this. That is one more way of solving the same problem, my dear friends. The post order traversal. You all know post order traversal. Of course, there are different methods. Every node we have to visit 3 times. Left, middle, right. Left, middle, right. Something is wrong in tree. No, division is having higher precedence, na? Division is having higher precedence. So D, acha, plus will come. Sorry. Yeah. I done mistake. Yes. Sorry. Okay. The last operation is plus. I am sorry. Last operation is plus. For the plus, left operand is C. Okay. This entirely gone then. Wrong. This entirely is wrong then. Sorry for that. Yeah. Sorry for that. I was C. Then for this it is division and D. Sorry. Yeah. Sorry for that. Right. You can draw expression tree and we can solve the problem, my dear friends. Yeah. Is that clear? Sir? Here also you always make this, then you will not make that mistake, sir. First this, then this. The last operation. If you can draw that particular which one is done first, then you will never do such mistakes. So here directly I return, so somewhere I messed up with that. Thank you. Right, sir. Next one. Here is an infix expression. Suppose we are using usual stack algorithm to convert the expression from infix to postfix with normal rules of operator precedence and associativity. What is the maximum number of symbols that will appear on the stack at one time during the conversion? Regular questions, sir. Please answer this. It should not take much time. Half-minute problems. So 3 is the answer. 4 plus 3 into is pushed onto the stack, then left symbol. Then 6 is pushed onto the stack, then into is pushed onto the stack. Am I clear? What happened, sir? 4 are there, no? Why 3 you are saying? The left parenthesis is also, okay, is counted. Whatever you are pushing onto the stack, they are all counted, sir. Whatever you are pushing onto the stack, everything is counted. Okay, independent of whether it is left parenthesis, right parenthesis, not just the operators. So 4 you are having, na 4 you are having maximum. Then after that 3 will come, then minus is having less than, then minus this star will be removed, minus will go there. Am I clear? Then 12 right parenthesis, so minus will come here and this is gone. Now all are done, no? So into minus, sorry, into plus will come. So 4, maximum 4 at any time, my dear friends, maximum 4. Okay. See, if you ignore left parenthesis, it may feel bad. Ignore that, don't ignore that. Now evaluation of expression. No. See, that is the problem, sir. One star is inside, but the other star will not be popped because there is a parenthesis that is happening within the parenthesis. So parenthesis will have higher precedence than that star operation. Okay, parenthesis will have higher precedence than the star operation. So because of the left parenthesis, it will not see star below that, my dear friends. Okay, it will not be popped out, my dear friends. Got it? 4 will be the answer. Pujara Babu, Pujara Raj. Shall I repeat it or what? There is a left parenthesis between them. You missed that. So here, sorry, it's gone here. Okay, let us do it here only. Now here we are going to use operand stack. Here we are going to use operand stack. So whenever you see operand, you push onto the stack, 2 push onto the stack, 2 push onto the stack. Now when you see the power, see power means first pop will give you the operand 2, second pop will give you operand 1. So 2 power 2 is 4, that 4 is pushed onto the stack. Then what happens, 4, 8 are there. Now there is a division. So division means pop, first pop will give you right operand, second pop will give you left operand. 8 by 4 is 2. Now push onto the stack. Then you got 3, push onto the stack. Then you got 2, push onto the stack. Then you have star. First pop will give you right operand, second pop will give you left operand. 3 into 2, that is 6. Push onto the stack. Then we have plus sign. Pop, first pop will give you right operand, second pop will give you the left operand, that is 2 plus 6, 8 is pushed onto the stack. Then after that 3 is pushed onto the stack, 1 is pushed onto the stack, star. First pop will give you right operand, second pop will give you left operand, 3 into 1 is 3. Am I clear? So that is pushed onto the stack. Now he is asking top 2 elements of the stack after second star is evaluated. Okay, second star is evaluated, top 2 elements. Top 2 elements would be 3, 8. That is option B. After, because second star is done, what about the stack top symbols? But if you want answer, just continue further. Minus, pop, pop, and 5 is the answer. Is the idea clear, Babu? A circular linked list is used to represent a queue. A single variable P is used to access the queue. To which node should P point such that both the operations NQ and DQ can be performed in constant time. So, if you are having pointer to which node, the NQ and DQ operations can be performed in constant time, my dear friends. A very common regular question. Front node, rear node, not possible with single pointer, go to hell. C. You can't do it with a single pointer, huh? Is it so? See, my dear friends, if I am having this pointer to the rear node, if I am having pointer to the rear node, okay, see, NQ is done at what end, my dear friends? NQ is done at rear end or DQ is done at front end. So, whenever you are NQing na, new one you want to NQ it, rear end, you are having pointer to this. See, actually rear link is pointing to front. What you can do is, this new PTR or new node we are having, what you can do, PTR link is front and rear link is equal to PTR. With this what happens? With this what happens? This will be inserted and you can call it as rear, my dear friends. You can call it as rear, my dear friends, or the last node. That is always, this is where you are doing NQ operation like this. Now if you want to do DQ operation, simply rear link is equal to rear link you can do it. That is, instead of pointing to front, you can point to the next one. You directly delete it, my dear friends. And of course you can update that front link, my dear friends, because we have a single pointer. So that single rear link is equal to rear link if you do it, obviously the DQ operation can be done. Both NQ and DQ can be done. See, node next to front, that is, he is asking node next to front, means for this he is giving a pointer. Kaustubh Nageshwar, he says node next to front. So here if you are having pointer, he says that you can do NQ and DQ in order one time. That is not possible. That is not possible at all. Okay. Is that clear, Kaustubh? Yeah. Let Q denote a queue containing 4 numbers. See, it was a problem with 16 numbers, but if you understand with 4 numbers now, you can easily answer that question with 16 numbers or 18, what are other numbers, you can do it. And SB an empty stack. Head queue returns the elements at the head of the queue without removing it from queue. Top S returns, that is, head queue means just tells you what is the front of the queue, my dear friends. Okay. And similarly, top S returns the element at the top of the stack without removing it from S. Consider the algorithm given below. While queue is not empty, what you are doing, if S is empty or the top element of S is less than or equal to head element of queue, then you are going to dequeue the element and you push it onto the S. Else, that means if stack is not empty or top S is greater than head of the queue, in that particular case you pop the element from stack, then you NQ in the queue, my dear friends. So this is the operation which is given, interesting operation. The maximum possible number of iterations of the while loop in the algorithm is. Have you understood? This is a very interesting. See, with queues, they are asking such interesting puzzle kind of questions regularly in the GATE examination. So you just need to have the idea of what is stack and what is queue. What do you mean by NQ? What is mean by DQ operations? with common sense you can handle such problems, my dear friends. They are all common sense puzzle problems, my dear friends. See, don't expect any programs in GATE examination. They'll give you program and they'll ask you to trace it. That they can do it. Am I clear? They'll not ask you to write the program. So in one way you are safe, in one way you are not safe, because you have to trace someone else's logic is very difficult. Okay. What is the answer? See, here we are having Q containing 4 elements. We don't know what are the elements in this, my dear friends. We don't know what are the elements of the Q, but he says that head Q returns the elements at the head of the Q. Head of the Q. Am I clear? Top S will give you the top of the stack element, it is going to give you. See the algorithm, my dear friends. If top symbol of the stack is less than or equal to head symbol, that is front of the queue, what you are going to do? You are going to remove the element from the queue and insert on the top of the stack. Sayal Malik says 4. You have to find maximum. See, I will tell you one idea, sir. Look at this. Suppose queue contains the elements 1, 2, 3, 4 and stack contains empty initially. Now top of the stack is empty, so you remove this and push onto the top of the stack. Now 1 is less than or equal to 2, DQ the element, push onto the stack. That is what you are doing now. When the top of the stack is less than or equal to head Q, DQ and push onto the stack. DQ and push onto the stack. Again 2 less than or equal to 3, DQ, push onto the stack. 3 less than or equal to 4, DQ, push onto the stack. So with just 4 elements on the stack or with just 4 operations, you can empty Q, my dear friends. So this while loop is completed. But he is not asking, he is not given this order. Na? Q order is not given to you. How can you take 1, 2, 3, 4? You have to find the best possible order where you can get the maximum possible iterations for this while loop. You have to get the maximum possible iterations. See, my dear friends, if I take this Q in the reverse order, in this case what happens, let us see. When I take the Q in the reverse order, what happens? First stack is empty, pop and push onto the stack. But here top of the stack is greater than front of the Q. Top of the stack is greater than front of the Q. Okay, no problem. In this particular case, what you do is, because if top of the stack is more, pop and NQ. Now it is again Q is empty. Remove this, push onto the stack. But again 2 is less than or equal to 3. See if the top of the, see the result, sir. Top S is less than or equal to head Q. Top S is less than or equal to head Q. If it is less than or equal to, then you are going to pop DQ and insert inside this, my dear friends. So here what happens? 2 you remove and you insert it. Now is it less than or equal to 3? Yes. Remove it and push onto the stack. Now 3 is not less than or equal to 1. So you have to remove this and NQ, my dear friends. Now again you are having 1. Okay. 1 is, 2 is less than or equal to 1? No. So 2 need to be popped here. 2 need to be popped and NQ'd, my dear friends. Now you push one stack is empty, remove this and push on to the stack. Okay. Now 1 is less than or equal to 4. Yes. Pop, DQ and push on to the stack. 4 is less than or equal to 3. 4 is less than or equal to 3. No. Again pop it and insert. See, if you actually observe this logic, what is happening, let us try to analyze that. When it is reverse order, first time 4 enters, but 4 is not less than or equal to 3. That is, it is popped, it is DQ'd from the queue, again NQ'd to the queue. That is, here what, how many operations happened? It is removed from the queue, again it is NQ'd to the queue. See, is asking maximum possible number of iterations of the while loop. See what is happening here, one iteration happened. Again what is happening, sir? Because 4 is not less than or equal to 2, again one iteration, this 4 will go up. Now if you see 2, for 2 what happened? It entered this, that is one iteration. Now 2 is less than or equal to 3, yes. So what happened to 3, sir? What happened to 3? 3 is pushed. But 3 when you pushed onto the stack, 3 is not less than or equal to 1. Again it is popped. See, for 4 there are 2 iterations happened. For 4 there are 2 iterations happened. For 3 there are 2 iterations happened. Now 2 less than or equal to 1, no. 2 is popped and enqueued. See, for 2 also 2 operations happened. Now for 1 is pushed onto the stack. Now this is by the time 1 is pushed onto the stack, my dear friends. Now is 1 less than or equal to 4? Yes. See, 1 less than or equal to 4, yes. So that is done. So by the time 1 is on the top of the stack, total 7 operations happened. Now you are having 4, 3, 2 with you. When you are having 4, 3, 2, 1, by the time 1 is top of the stack, you done 7 operations. Similarly, by the time 2 come to the top of the stack, you do how many operations? You do 5 okay, I am blocking it. Let me write it here. By the time 1 comes to the top of the stack, you need 7 operations. Now you got 4, 3, 2 in the reverse order. By the time 2 comes to the top of the stack, we need 5 operations. Next, by the time 3 comes to the top of the stack, we need 3 operation, and by the time 4 come to the top of the stack, we need 1 operation. So sum of this would be 16, my dear friends. This question was asked in GATE with 16 elements. I just solved it with 4 elements here. See, whether it is 16 elements, 4 elements, or whatever it is, what you need to understand is when it is one, total 4 elements are there. When it is in the reverse order, the last element, by the time it comes, every element will pushed onto the stack, again enqueued onto the queue. 2 operations need to be done. That is, the first 15 elements are pushed, again enqueued to the queue. So if queue is having 16 elements, for the first element what happens? Every element pushed, enqueued. That is, first 15 elements are pushed and enqueued. That is 30 operation. Then 1 is pushed onto the stack. So 31 operations will be done by the time 1 is on the top of the stack. And by the time 2 is on the top of the stack, because for 2 means total 15 elements are there, 28 plus 1, 29 operations will be done. And for 3, it is 27. Continuing this way, last element it would be 1. Sum of this is the required answer, my dear friends. Actually, sum of first 16 odd numbers. It is actually sum of 4 odd numbers. The answer is 4 square, which is 16. It is actually sum of first 16 odd numbers. See, sum of first 16 odd numbers or sum of first n odd numbers is given by n square. That is 16 square will give you the required answer, which is 256 in this case, my dear friends. Okay. See, if you understand the logic with small examples, that can be generalized with 16, or if it is 32 also you can answer it. So the answer would be 32 square. Suppose if there are 32 elements are there, 32 square will be the answer for that. Square is the answer. Yes, n square is the answer. N square will be the answer for this. Whatever elements are there, that square will be the answer for this problem, my dear friends. Hope you understand. Is the idea clear? Yeah. Even this was the GATE question. Again, for this there were many discussions. We are having Q1 containing 4 elements and Q2 containing none of the elements. The only operation allowed on these two queues are NQ and DQ operations. The minimum number of NQ operations on Q1 required to place the elements of Q1 in Q2 in reverse order. See, the idea is how many minimum NQ operations you can put the elements of Q1 into Q2 in the reverse order. That was the question. See, what I want is final answer. This is what I want, final answer. This is what I expect. With how many NQ, minimum number of NQ operations on, see the question is the minimum NQ operations on Q1. Minimum NQ operations on Q1, I have to reverse these elements into Q2, my dear friends. See, the logic which we use here is Q2 is initially empty. Actually, with Q2, can you reverse the elements? Only using Q2, can you reverse the elements, sir? Can you reverse the elements with Q2? For example, if you are having two elements, I can NQ1, I can NQ2, then I can DQ1 and I can NQ it. So, two elements I can reverse it. In the reverse order I can get it. Two elements are there, I can do it. But three elements I cannot do it. When three elements are there, reversing it is not possible. Reversing it is not possible. So, what we do here is direct reversion, we don't do it. We do it in this way. First element we NQ it, that is we DQ and NQ in Q2. I am doing NQ on Q2, sir. Then second element I got it, I NQ on Q2. See, whenever I insert the new element, what I do is I do DQ and NQ operations such that the new element come to the front of the list. That is the logic I am using. So here what I do is immediately, because the new element 2 is inserted now, I DQ it, I DQ1 and I NQ1. So whenever new element is inserted, what happens? All the elements are DQ'd and NQ'd, DQ'd and NQ'd till that new element come to the front of the queue, my dear friends. Till the new element come to the front of the queue, my dear friends. Now this is what happens after 2 is inserted. Now Q, now 3 is insert NQ3 in this. Now NQ3 in this. NQ3 in this, that is 2, 1, 3. Now the story is same. DQ2 and NQ2. Now DQ1 and NQ1. I got the reverse. I got the Q reverse, my dear friend. And here I am doing only NQ DQ on Q2. Q1 is not touched. I just removing from Q2. Again I am not touch. I am removing. I am DQing from Q1. Again I am not touching Q1 at all. Now again I insert the new fellow. That is NQ4. DQ from DQ4 from Q1. That is 4 will come, that you have to NQ in Q2, my dear friends. So 4 is NQ'd. Then what happens? Again DQ this element and again NQ this element. Again DQ the first element, NQ the element. Again DQ the first element and again NQ the element. So with this what happens, sir? You are doing only DQ NQ operations on Q2, but Q1 no NQs done. So the number of NQs done on Q1 will be 0, my dear friends. The number of NQs done on Q1 will be 0, my dear friends. So that is the logic for solving this particular problem. Hope you understand. Hope you understand. Okay. Now let us take problems on hashing, my dear friends. Given the following input 4, 3, 2, 2, all these inputs are given and hash function mod 10 function is given. Which of the following statements are true? Which of the following statements are true? It's mod 10 function, my dear friends. Simple straightforward question. See, when you are using mod 10 function, the last digit and the index of the table, okay, that is where it will be actually hashed. That particular key will be hashed to that particular fellow. See, actually all these fellows will be hashed to the same value, that is ninth index, but due to collision, maybe linear probing, whatever technique is used, that particular technique will happen. So for all these fellows, they are all hashed to the same value, that is correct, even which are ending with 1, because mod 10 percentile 10, so the last number is same, means they are all mapped to the, or they are all hashed to the same value. So these two are correct, 1 and 2 are correct, A, B are correct, my dear friends, but all elements hashed to the same value is wrong. All elements hashed to the same value is wrong, and each element hashes to a different value is also wrong. See, hashing, they are hashed to the same value. Later on, that collision resolution technique is used, but they are hashed to the same value. That is the point to be noted. Next one, which one of the following has functions on integers will distribute the keys most uniformly over 10 buckets numbered 0 to 9 for I ranging from 0 to 20, my dear friends. So which one is the better hash function for this? See, better hash function means it should hash all the values uniformly to all the keys. Okay, very good. See, my dear friends, when you take square function, you all know the square of any number does not end with 2, square of a number does not end with 3, square of number does not end with which numbers? A square of a number does not end with which of the numbers, my dear friends? Square of a number does not end with which of the numbers? You can just think about 0 square, okay, 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square. So you see only numbers will end with 0, 1, 4, 9, 6 and 5 only. Am I clear? And when you are doing mod 10, all the fellows can be mapped to only these indices. Am I clear? So there is no 2, there is no 3, there is no 7, there is no 8. That is, these indices or these table values are always vacant initially. Of course, later on if you use some linear probing or something, it may happen, but this is not uniformly hashing all the keys to different buckets of the table, my dear friends. So this is not a proper one. Even 11 into I square means if you multiply with 11, the last number will be the same. The last number will be the same. So even this will map to these buckets only mainly. And if you see 12 into I square means, see, whenever you multiply any number with even number, the last number will be even. That is, all even buckets are uniformly hashed, but odd buckets never hashed. So these three fellows are having problem because not all buckets are uniformly used. Whereas when you use I cube, 0 cube is 0 cube, I am talking about the last digit. 0 cube is 0, 1 cube last digit is, this is the last digit. When you do 0 cube, 1 cube, the last digit. Because we are doing percentile 10 na, the last digit is very important. When you do 2 cube, that is 8 is the last digit. 3 cube means 27, 4 cube means 64, 5 cube means 125, 6 cube means 216, 7 cube means 7 7 49, 63 or 3 is the last digit, 8 cube means 64, 2 is the last digit, 9 cube means 9 will be the last digit. See, you see 0 is there, 1 is there, 2 is there, 3 is there, 4 is there, 5, 6, 7, 8, 9. So all the buckets of the tables are uniformly used. So there is a possibility of uniformly hashing all the buckets. So this is the best one, my dear friends. Okay. So this will distribute the keys uniformly in all buckets, whereas the other hash functions are having problems because some buckets will never be hashed at all directly. Maybe with the collision resolution they may be used, but directly they are never used, my dear friends. So this is the best hash function. Sorry. Given the hash table T with 25 slots that stores 2000 elements, what is the load factor, my dear friends? All of you know load factor. Load factor, number of keys to be stored by number of slots, or number of buckets, or number of indents, whatever you say, number of slots. So direct questions are load factor, directly you can identify, which is 2000 divided by 25, yani 80 is the answer for this. Okay, for those who do not know, it's a simple formula, sir. Number of keys, how many keys are there, how many buckets are there. So you will get the load factor for each bucket, my dear friends. The next one, the key is 12, 18, 13, 2, 3, 23, 5 and 15 are inserted into an initially empty hash table of length 10 using open addressing with hash function hk is equal to k mod 10 and linear probing. What index does the key 23 maps to? So 23 is mapped to what index? See, because linear probing is also mentioned, so after complete linear probing, finally where 23 is what index 23 is placed, that you have to mention. So here we are having mod 10 means the possible indices are 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Wonderful. Super. 3 Venkateshan, why 3? See, first 12 has to be mapped to this, then 18 will be mapped to 8th index, then 13 will be mapped to 3rd index, then 2 is mapped to 2nd index, but that position is already filled. So linear probing means next vacant place it is also filled, next vacant place 2 will go here. Then 3 actually hashed to this 3rd index, but that is full. So next one linear probing, next vacant, next slot is not vacant, next slot 3 will be placed here. Now comes 23. By the time 23 comes here, that is already filled. There is a collision. It goes to the next place, that is also filled. Next position, that is also filled. Next position, this is where 23 is placed. So 23 is placed at 6th index, my dear friends. 23 is placed at 6th index, my dear friends. See, the same question they can ask you with double hashing, double probing. Okay, double hashing, not double hashing, sir. Quadratic probing. Quadratic probing means 0 or 1, yeah, 4th cell from that particular position, yeah, 9th cell, that is square of the positions we are going to probe, my dear friends. Right? Consider a hash table with 9 slots. The hash function is hk, which is equal to k mod 9, yeah, I square, correct Venkateshan. The collisions are resolved by chaining. Chaining is used for collision resolution, separate chaining we call it. The following 9 keys are in the order are inserted in the order 5, 28, 19, 15, 20, 33, 12, 17 and 10. The maximum, minimum and average chain lengths in the hash table respectively are what? A. Deepak Gupta says A. So here, because it is mod 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the keys need to be mapped, my dear friends. 5 percentile 9, 5. Then, sorry, it's going back. 28 percentile 9, it is 1. 28 will be mapped to 1. Then 19. 19 means what is the remainder? 9 2 is 18, 1 is the remainder. 19 also mapped to the same fellow. Then 15, remainder is 6. Then 20, remainder is 2. Then 33, 6 is the remainder, 6, that is 33 will be this. And 12, 3 is the remainder. And 17, 8 is the remainder. What is it? 17, no? And finally 10, 1 is the remainder. So here if you see in the chaining, maximum chain length is 3. Minimum chain length, there are some chains are not yet started. So minimum chain length, maximum length of the chain is 3, 1, 2, 3. Minimum length is 0. Then he is asking average length. Average length means for every fellow you have to find the chain length 0, 3, 1, 1, 0, 1, 2, 0, 1, 0. Total how many are there? I think it is 0 to 8 only. I am sorry. This is 0 to 8 only, sir. Because percentile 9, na? Oh, 1 second. Okay, sorry for that. There's some battery issue. I think now it should be okay. Okay. Fine. So divided by 9. So I think it is 3 plus 4, 5. 4 plus 1, 5, 6, 6 plus 2, 8, 8 plus 1, 9, 9 by 9, it is 1, sir. 1 is the answer. So 3, 0 and 1 is the answer for this. 3, 0, 1 is the answer for this. The next one. Please answer this question, sir. The next one. Consider a hash table of size 11 that uses open addressing with linear probing, and this is hk is equal to k mod 11 be the hash function used. A sequence of records with keys are given is inserted into an initially empty hash table, the bins of which are indexed from 0 to 10 obviously, because 11 is the size of, 11 is the what you call the size of the table which is used. So obviously 0 to 10. What is the index of bin into which the last record is inserted? So you have to tell where the last record is inserted, my dear friends. Answer this question. So these are 43, 36, 43, 36, 92, 87, 11, 4, 71, 13, 14. Right? So you have to tell if it is indexed into the regular hash table of size 11, the index are from 0 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Am I clear? So you have to use this, and linear probing it is. Am I clear? Linear probing is used. Happy situation. So happily insert and get the answer. 43 percentile 11. What is the remainder, Babu? 43 remainder 11 means? Acha, final answer you given. Very good. 43 remainder means what, sir? 43, I think 10 is the remainder, right? 10 is the remainder. 36, 3 is the remainder. 92, 4 is the remainder. 87, 10 is the remainder, but 10 is occupied, so 87 will go because of linear probing. 11, 0 is the remainder, but 0 is already occupied, so it will go to the first location. 4 is the remainder, 4 is occupied, so 4 go to the fifth index. 71, 5 is the remainder, fifth index is filled or fifth slot is filled, so next position it will go. 13, 2 is the remainder, 2 is happy. 14 means 3 is the remainder, so 14 cannot go here, cannot go here, cannot go here, so obviously 14 will go to the 7th slot. So it will go to the 7th slot, my dear friends. The index of the bin into which the last record, that is 14, is inserted, that is equal to 14, my dear friends. Next one. Given hash table with 13 buckets with one slot per bucket and all slots are initialized to 0. Insert the following keys into hash table using a hash function percentile 13 with linear probing. Okay, what is the load factor of the hash table, my dear friends? See, load factor means, for example, in this case, what is the load factor? Can you tell me what is the load factor in this case now? In the previous function, what is the load factor? Total number of slots is 11. How many keys inserted? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 11. That is the load factor. So here what is the load factor if you insert them in the table with linear probing? Oh, I think, sorry. Sorry. With linear probing. Okay. Yeah. One second. Yeah, what you are doing? See, denominator is number of slots. Number of slots is 11. Numerator is number of keys. How many keys? 1, 2, 3, 4, 5, 6, 7, 8, 9 keys. 9 by 11 is correct only. Not 11 by 9, 9 by 11 is correct. This is number of keys to be inserted. This is number of slots. I thought I made mistake. Suddenly when I see something, I only get confused. Huh? Sorry for that. See here, one thing we need to understand is with linear probing, we can always can get the next vacant slot. See, till all the slots are filled, definitely with linear probing you can easily find that. But the only thing is the primary clustering, the big cluster you have to move down. Am I clear? So that may be the case, my dear friend. That may be the problem with this linear probing. So you don't have to push them in a what do you call the buckets and verify. Total how many keys are there? Total keys how many are there? 10 keys are there. How many buckets are there? 13. So load factor you can directly calculate, sir. For that you don't have to solve the problem, sir. Directly 10 by 13 will give you the answer. 10 by 13 will give you the answer, my dear friends. 10 by 13 will give you the answer. Is it 10.76 or 77? 10.76 या 77? D is the correct answer. Wonderful. So don't have to solve it. Directly load factor you can use it, get the answer for this. Okay, one more problem. Consider a double hashing scheme, a recent GATE question only. Double hashing scheme is given. Okay. See, double hashing scheme formula would be HKI is equal to first hash function plus I times second hash function mod number of size of the table. Size of the table. Babu, what is the correct answer for previous one? Are you using calculators or not? 10 by 13. Let me use my calculator. Sometimes I use calculators also. 0.769. 0.769 means 77 only, na? C only we take it. How can you take 76, sir? Rounded to 2 decimal points. Yeah, 0.77 only. Yes. Not truncated, na? Rounding to 2 decimal points means it has to see, we have to see 0.769, na? It is more than 5, then it has to be increased to 77. Someone given, I just written that answer. Yeah. So here H1K is K mod 23. K is what, sir? 90 mod 23. Because here probe 1 only, so I is equal to 1 only. H2 means what, sir? 1 plus 90 mod 19 mod 23. So with this you get 90 mod 23 means what, sir? 23 threes. What is it? 23 threes is 23 threes or fours? Fours. Fours will be more, na? 80, 120. So what is this? 23 threes, I think 69. 69 means 21 will remain. And here 1 plus 19, how many times? 19, 5 sir. 4 sir. 76, 76 means 14, 14 plus 1, 15 will remain. Mod 23. So 21, 30, 36 mod 23, which is 13, my dear friends. Okay. So we are done with this today's class, my dear friends. Okay. Now we are having this particular general aptitude coming soon by Rakesh Talreja sir. Please do attend this to score maximum marks. Quick revision of your general aptitude. Then there is a mathematics session by Rakesh Talreja sir and Ankit Joshi sir coming up, my dear friends. And there is a mega workshop by Mr. Abhinav Negi sir on 15th January at 12:30 p.m. on your BYJU'S Exam Prep app. Yeah, I is equal to 1. If I is equal to 2, you can just put appropriate value, sir. See, I is equal to 1 because probe 1. Because probe 1. Today write on time. And you can also opt for this GATE full test series, my dear friends, where you have this full length mock tests and subject wise tests which are curated by the experts, and we have detailed mock test analysis also given. Am I clear? Virtual scientific calculator, so that you can feel like writing your GATE examination only. Am I clear? And there are so many practice questions from this. These practice or test series questions will be given to you, right? So that's all for today, Babu. Any other doubts you can ask me? Otherwise, we'll call it a day. That's all for today, my dear friends. That's it. See, probe 1 means what, sir? See, probe 1 means what, sir? Probe 1 means initially that mapped to which fellow? Initially it is mapped to I is equal to 0. Then I is equal to 1 first probe, where it is mapped to first probe. That is the meaning of that, my dear friends. Probe 1 means that. See, whatever probe number is there, you put that I value accordingly. That I refers to the probe number. I refers to the probe number, my dear friends. I refers to the probe number, my dear friends. Hope you understand. Yeah. So, where you are starting with 1, sir? See, generally probe starts at 0 only. But he is asking in probe 1 what is it is going, where it is going. He clearly mentioned in probe 1 where it is going. So there may be some collision. We do not know about the previous history, sir. We are asking about 90. So 90 may be with probe 0. 90 is just same as your primary hashing only. That is H1K only. 90 is originally mapped to 21. That there may be a collision. At 21 there may be a collision. So that's why you are going for probe 1. You start with probe 0. Probe 0 is same as H1K only. Probe 0 is same as H1K only. Always we use primary hashing function only. When it fails, then the secondary. See, double hashing comes in play when there is a collision. I is equal to 1 onwards, that second hash function will be used. Otherwise, second hash function has no meaning at all or no use at all. Hope you understand. See, because we do not know any information about other keys, he is just asking about 90 and is asking probe 1 means we assume that okay, there may be collision, that's why he is asking for probe 1. That is the question. Hope you understand. Is the idea clear? Wonderful. Thank you, sir. If you have any doubts, you can ask me. Otherwise, I am calling it a day. Thank you very much.